All right. Well, thanks everybody for joining us for the February 2014 online builder hangout from Cleveland Aircraft Tool. I'm excited. It's been a few months since we've had one, and I think tonight is going to be a pretty exciting one. Selfishly, I've had more than a few questions for Mike over the last few months as I've been getting going on RV9 tail kit. And one of the first conversations we had as I got a couple steps into the plans was fabricating a piece of attach angle to the horizontal stabilizer spar. So that's, being my first time building, personally, it was certainly quite a curveball, but I think through having some conversations, Mike and I both tackled a couple of problems and decided that this would be a great topic for our first hangout back in the new year. So thanks everybody for joining us. I want to go ahead and run through a couple of quick housekeeping items here. It's about 5:35 now, Pacific time, 7:30 Central, and we're going to run for about an hour. And as people, we will invite you all just during the event to go ahead and utilize the chat window, or the chat feature of Google Plus in the upper left-hand corner of your toolbar, as well as the Q&A section. Those Q&As actually get posted out to our Google Plus page, which is helpful for other people looking for information as well. So feel free to use either of those features. I'll be monitoring both during the session, and I'll be flipping those questions over to Mike as we get them, or in natural breaks in the Hangout. So Mike, I'll go ahead and hand it over to you.
What we're going to talk about today is fabrication and making parts from scratch, rather than a lot of the parts we do in RV work is just assembly of prefabricated parts. So we're going to talk about that. We're going to start with a piece of angle and make a part from angle, and then I'm going to cover, I don't know how well the time will work out, but I'm hoping to also cover just a fabrication of something out of a piece of sheet metal, like when you would put a landing light in, for instance, or the instrument panel, anything like that that maybe has a weird hole that you cut out of it. So I'm going to talk about those things, and when we're done with the Hangout, it'll post on YouTube automatically, but then later, hopefully tomorrow, I'll get in there and I will go through and make a list of the different topics in the Hangout and put a timestamp on them. So again, if you're watching this later, you'll be able to click on that timestamp and just jump to that area you're interested in, like using a bandsaw to cut a piece of extrusion or something. So just wanted to go over that real quick. So we're going to talk about intent when you're laying out a part to fabricate, how you intend to use it, how you intend to build it. We're going to talk about some tips I'd like to give on measuring and layout. Then we're going to get into cutting and filing by hand. And I'm going to play a few videos I took earlier today of cutting and sanding using power tools that many home builders decide that they will use in their projects. And then again, at the end we'll get to working in thin metal, using snips, and then once you use snips, getting up to the exact measurement that you need. These kind of are lost skills in a lot of the new kits that the parts fit so well, punched on CNC punch presses and stuff. But we're seeing a lot of people do a lot of custom stuff again, where we didn't see that for a while. Also, one of the things that Bill had a question on is being able to drill a hole straight through a piece without using a drill press. So I have a little trick on that I'll show. So let me get into it. First of all, I'm going to share my screen that has a PDF of this part that I'm going to make here. This is it's an R405. That's some kind of attached bracket that goes on a rudder, I guess. The way this came about is I asked Keith at our local Builders Assistance Center. I said I could build something, just to build it, but what do you guys need fabricated anyway? And that way you can have a part at the end of it. So he came up with this. Is it a control horn bracket, maybe? That you see on the screen here. And I switch to my other screen, I'm going to talk a little bit about design intent here. So you see on the on this print how each of these areas is spec'd out. And one thing to notice is, where did it go? Bear with me. Okay, right here it says drill in assembly. So these holes here, I'm going to go ahead and lay out right away, but those don't get drilled until you put it on the piece, so I'm not going to drill those. I will drill the holes for the nut plate and the 2 attach holes for that. So one thing about design intent. So this part is a symmetrical part about the center line. Now it gives some of the dimensions in the symmetrical way, I guess you would say. It's 3.5 across here. But then it shows that this point here, I don't have a very good pointer, but this point here is 2 inches from one edge. Now, if we were to lay it out that way, we could go 2 inches from this edge and 2 inches from this edge and not end up with the right distance. Now, this is cosmetic, where they're talking about here, but what I like to do is I like to go through, if it's a symmetrical part like this, to avoid cumulative error, I like to just take all of these and divide them in half. So here we have, what, 2 3/8 plus a half, so 2 7/8. So that's how I would do this, and then I would put my center mark on the piece here, and then go each dimension from that to wherever I'm measuring. That way, it will be a symmetrical part, and imagining it on the airplane in a different place. Say the part was a 1/16 of an inch too long, and that whole 1/16 hung out one side of the airplane. You know, you noticed it on one side, you didn't notice on the other, or it bulged the skin out on one side. You know, whatever happened to be the case for that particular part. Where if all the dimensions are baseline dimensions, if they're all from one side here, then then I'll go ahead and make it that way. But it really depends on how you intend to use the part, and it also depends on how you intend to make the part. So the next point is how I'm actually going to make this. Now, what I've done here is I've gone ahead and made half of it, and the other half is not made. And the reason I did that is just for time management reasons here, and to also show you some of the ways to do it with a power tool. So this part was made, I don't know, 10 minutes, 15 minutes, something like that, with a bandsaw across here, and then a file and deburring wheel, basically. Oh, I think I used a belt sander. No, the belt sander was just on the end. But I'll cover that in just a minute. So my intent, how I'm going to lay this out, normally I would not do this piece first. Normally what I would do is I would drill whatever holes, the simplest, easiest things to do, I would do first. That way if you screw up the part, you don't do the hard work twice. So I leave that for the end, and that way if I screw up the part at the end, all I have to do is go back and drill holes. Maybe you would wait to attach the nut plate just to be safe or something, but that's my philosophy in making a fabricated part like this, is I want to do the easiest stuff first. So like I said, I was going to I wanted to cover design intent, and then I'll get into measuring and layout here. But now this piece, the other side, I'm going to do in a vise with a hacksaw. So I need to think about how I want that to be in the vise. Do I want to put it in this way and be cutting this way? Do I want to be this way and cutting this way? Can't think of other options. Perhaps like this. So you decide if you want the lines on the inside or the outside. That's an important part. Same with the drilled holes. Do I want to lay this down flat on the table, or do I want to put it over a wood block in the drill press? Depends on how you lay it out. So I just wanted to cover that real quick with the intent of how you're going to do this. this is a pretty simple part, but you can apply this to more complex parts. So what we're going to do is lay out some of these things. I'm going to do it on the outside because that's the way I want to cut it. And it says on my print here that this point is 2 inches over from this edge, and again, I would normally go from center line doing this, but for ease of this example, I'm going to go 2 inches over to this point here, and then this is 7/8 of an inch to where it starts. So what I do is I line the graduation mark up on the edge of the material, and you can see this is on the bottom. It's graduated in 64ths of an inch. On the top, it's 32nd. So I can easily read the ruler to a 64th of an inch. I wonder how close this camera will get. About that. Okay. So, and probably I can split that and read it to 100th of an inch or so. So I have that exactly on the 2-inch mark, and then catch up here. Then I go ahead and I mark my part at the end of the ruler. Now you can, and while I'm at it, I'll make a little flag on that. I do the flag so that I know which side of that mark I measure to. So I know that this side of the mark is exactly 2 inches, and then this is just the thickness of the marker. So the reason I do that is, let me flip it over, and I'll line up the ruler exactly with the end of the part, which is very easy to do, of course. Then you come back over here and you try and mark exactly 2 inches, and that's a little more difficult. Can be done, but it's so much easier to use the ruler backwards from the way you would normally use it. So I'm put a little flag down that side, and I'll actually just use a square to extend this up. I should have marked it right at the top. And then just connect the dots. So I'll go the side of the line closest to the edge of the material. Now, do I want to cut on which side of the line? I want to cut on the other side of the line, so I make my tag over here. And again, for this particular application, it's obviously not important, but if you get into the habit, you can always very, very accurately mark your stuff. And so then I'm going to make a squiggly line over here, just so I remember that it's not exactly in the right spot, but that's what I want to do. So now on the inside, I want to make that 7/8. Okay, so I'm going to put it in the vise. So this vise, first of all, is not attached to the table, and it's always a bad idea, but that's what we're working with here. This vise has brass jaws. One thing I wanted to mention is, if you have a standard hardware store, home center vise that has the steel jaws with the knurling on them for grip, one thing you can do is just take a piece of the aluminum and make a soft jaw, so to speak, that just lifts over each side. Just take a piece of extrusion and do that. I've seen people do similar things with wood, but it's a good way to protect your materials. So what I'm going to do here is I'm just lining up. This is the reason I don't have the vise attached to the table. I'm going to line up the saw and leave about one saw blade width away. Away from the part here. So I'm just going to cut straight down. Okay, so I have that cut made straight down. Or if I'm standing in front of the camera the whole time, was that the case?
No, just for the last 5 seconds or so, you're fine.
All right. So now I want to orient this so that I can, again, I want it pretty much vertical because I want to be able to I can hold the saw vertical. It's hard for me to hold the saw at a specific angle. So I'm going to try and make this as vertical as I can.
So Mike, since you were talking about the vise, we had used a 90-degree clamp on the table here. And one of the things I noticed on a couple of the test pieces I had done, it left some scratching on the face of the aluminum. And, it was a little bit deeper than Scotch-Brite pads could clean up. But what's kind of the tolerance for knowing how scratched is too scratched on this type of material?
On this type of material, you're going to prime it anyway. It's all extrusion. So as far as a scratch that it would be like in a skin, that's not a concern because you're going to prime it. I always try and make stuff so you can't feel it. When you drag your fingernail across it, I don't want to feel the mark. So what I'm going to do here, I didn't mention this when I started it last time, but when I start it, I do pull the saw backwards because you can make just a little nick in it without the teeth trying to grab. On the part number is actually 24, and then there's a 32 and an 18. So those are threads teeth per inch. And the rule of thumb, I was always taught anyway, is you want to have 1.5 teeth per thickness. Okay, so I'm just going to go straight down again. Only pushing down when I go forward. I want to use the entire stroke of the saw so that my blade is the teeth are being utilized the best. Trying to speed this up so nobody goes to sleep. That's why I did one of them earlier. Now I'm supporting the part because it's going to want to tear. Aluminum is so soft at the very end.
Hey Mike, one quick question. Brian asked if the tooth count on the saw blade for the hacksaw would be the same as the bandsaw or similar to a bandsaw blade.
Yep, it's always 1.5 teeth in the material. Yep, good question. Okay, what I'm going to do next is I'm going to use the Vixen file, and they're sometimes called curved tooth file. Vixen has been making them since, what was it, the 30s or 40s or something like that. So it's a curved tooth file, and it works very much like wood plane works on wood. So anytime you have a long surface, you can go along it with the Vixen file, and it really quickly removes material. Now, thicker metal like this, again, when you have 1.5 teeth worth in the material, it works pretty good. And you see from the edge that there's two different, maybe you can see from the edge, there's two different teeth count. There's a fine side and a coarse side. So I'll try with the coarse side first. Let me kind of count. There's about 4 teeth in the material here. But obviously the coarse side is going to take away the material way faster than the fine side. And I'm just going down until basically all my efforts are to do as little work as possible. And so I'm going as close as I can get without marring up the surface here, which I did a couple times. You can actually protect that by using a piece of masking tape if it was a part that you were really concerned with. And I can see, I don't know if you can see it in yours, yeah, I'm getting more here than here. So I'm going to start putting pressure only on this side of the file. Alright, so there I'm pretty close as far as being flat along here. You can check along with the square and make sure that everything is good. It's, super important. So now I'm tempted to come up here and I'm tempted to work on this. But again, keeping everything comfortable, I need to change it. I need to spend 30 seconds and change the way I'm doing it. And here, what I'm going to do is I'm going to use a little gauge, doesn't matter what it is, to make sure I'm parallel with the vise. Okay, so I'm almost down to the line. I'm just going to finesse in this corner just a little bit more. Okay, this is a mill file, and this is what you see a lot of times just as a standard file. But it's, I guess I don't know the reasoning it's called a mill file, but it leaves almost like a milled finish. That's how I always think of it. I'm going to come back to that in just a second. This is what's called a multi-cut file, which is a mill file that has some cross-hatching in it. That breaks your chips, so your chips don't load up in the file as much. This is specifically made for aluminum, and it's the Simmons aluminum file. It's kind of like a mill file with a lot of crosscuts in the teeth because it's made for aluminum, and you don't want to load the aluminum up in the file. And then this is just a rat tail round file that I pulled out. There's one over here that's a triangle. That's great for getting into inside corners. You can get in there and really square up corners. So you want to have a good file set. You want to have a lot of different options that way. Now, the multi-cut file on top, this one, and the mill file on the bottom, let's look at the edges. Now, I've taken a grinder to these edges of this bottom one, and I've made what's called safe edges, or they're semi-safe really. They're not exactly done right, but they don't have any teeth on the edge, versus this one that has teeth on the edge. So with this one, you can get into a corner and you can clean the corner up with the edge as well as the top, so you get a nice square corner, which is handy sometimes. Sometimes, a lot of times, it's handy to be able to get up to something and not remove material, but only on one side. So let's see, I'm going to use the mill file because I'm getting right down to my line and I want the finish to be nice. I'm going to check across this way and make sure that I'm getting everything square. It looks like the inside needs to go down a little bit more than the outside. So, okay, so the finish on this now is quite nice. In fact, it's almost as good as you would get, you know, bringing it to your deburring wheel and doing it that way. It's a little sharper on the edges, not quite as smooth here. But I still have this corner area and this flat area to clean up. And I'm just going to get the last of those little file marks out so it's nice and smooth. Now we saw with Ben's latest service bulletin how important it is to make sure you don't have any places for cracks to start. There was one of those had a relief hole, or what was it called? A radius that was meant for a stress relief, but they still cracked in there. So even you know, if you had a radius and you left a nick in it, it's a good place for a crack to start, and that's something that you don't want to do. Since I don't have it here, I'm just going to strike off a little chamfer on the inside and the outside. I'm going to knock off the sharp on the corner here, carry it around the edges. This top there was left pretty sharp with that Vixen file. Back piece, corners. I would be doing this on the bench if the camera was pointed in a different direction, but you get the idea. Just take all the sharp stuff off. Well, people are asking questions, and I'm going to show you how I did it earlier with the power tools. So this is a standard miter saw that a lot of people have in their shops, or if not, their neighbor probably does. It is important that you use a carbide tooth blade. Regular high-speed steel blade will not work for this. But it's surprising how well a standard carbide tooth chop saw will cut aluminum. So here's me cutting this extrusion to size, to length earlier. You want to make sure that you get it so that a tooth is not going to catch, and that's why I drew it forward right here and then back. I didn't want that tooth to catch that edge there. That's the critical point. So here is the bandsaw, and I marked this on the inside because I wanted it cut up against the table. But again, I just cut about a blade width away from the flange there. And this is a nice metal cutting bandsaw. The wood cutting ones a lot of people have for their home shops with the metal cutting blade will work also. But you do have to make sure you get the right kind of blade, fine tooth blade, and you have to make sure that it gets cleaned out because they do not like aluminum chips in them. So if you cut aluminum with a cutting bandsaw, make sure you get it clean afterwards.
Hey Mike, can you repeat the type of blade that you used in the miter saw?
Just a carbide toothed blade. So wood cutting blades like that will come in high-speed steel or carbide. Carbide probably twice as much money, maybe not quite, but it's the only thing that'll work in aluminum with carbide teeth. Okay, so here is just an example of using the belt sander to take that last little bit off to get up to the line. So again, it doesn't matter if it's a straight cut like this, or if it's a angle, or if it's say a radius or something. You can just cut close and then work down to the line. That just brings up something I hadn't thought of. But like if it was a radius cut, I would lay out the radius and I would cut little wedges into that radius, and then they would drop off as you cut around that corner. So that would be a way to get that done as efficiently as possible. Okay, the last one is the 3M wheel. I'm sure that you're all very familiar with this, but it works great to just bring it right down to a line. They remove material pretty quickly, so you can get rid of all the saw marks that way, much easier than a file. It does tend to round the piece a little bit if you're not careful, but it's the best aluminum worker's best friend, I think.
Hey Mike, we had one question about the grit of the sandpaper that you're using on the belt sander. What's the recommendation there?
Probably to do something like this, I would look for maybe 80 grit, 120 maybe. 60 would be too coarse unless you're gonna get down, grind a bunch off and then switch belts to say 120. But 80 to 120 would be what I would want to use for something like this. So what I would do on this piece is, if I can get the light to not be obnoxious. Okay, what I would do on this piece is I would drill like a number 40 hole in the corner here, and another one in the corner here, and here, and here. And then I would start looking at what I can do to hog this out as fast as possible. And a 3/4 inch unibit is going to take a pretty good size chunk, but then what do I do with this piece over here? So since this is a 1-inch hole and I have a 1/2 inch unibit, if I laid out a series of holes that were 1/2 inch, calibration on my circle is slightly off there, I could get pretty close here and then just have a couple little wedges to take out. So then if I did that all along here, I could say if I was using a drill press, I could knock those out. Before I did that, though, what I would want to do is I'd want to come in here like with a 3/16 bit and lay those out. So I'm taking out all these wedges with a 3/16 bit. And then, because the unibit's not going to care as it's drilling this big hole, it's not going to care about this having a segment of it gone. So again, just drill all those 3/16 holes, drill all the 1/2 inch holes, you're pretty close, and then start in with your file work. Okay.
It looks like we had one question here from Brian about the piece that you're just showing us, knocking out that for the LCD display.
Yeah.
He was wondering if that's the best type of technique to use on the leading edge for landing light.
That's a lot of chunking out for that. I would do that landing light one of two ways. I would definitely do this in every corner because that's the easiest way to get a corner done. Sorry, I'm thinking while I'm should be talking, but the other two ways, one would be with a die grinder and a cutoff wheel, not a Dremel tool. People burn Dremel tools up every time they try and do anything on an airplane or aluminum work. So an air-powered die grinder with like a 3-inch cutoff wheel. One thing you can do there is you can put like a piece of steel strap along there to kind of protect your work, because a lot of times they want to jump, and that way it doesn't jump into the good part of the airplane. So that's one way that kind of control that a little bit. What I would probably do with a landing light is I would use the nibbling tool. I would put it up from the inside so that when it punches, I need to explain how this works first. Okay, so when it punches, it has a cutting blade that comes down and pulls it into the material. So I wouldn't really want that to be on the outside, even though, sorry, I would want this to be on the outside so it punches the burr to the inside, even though you're going to go through and clean it up later. But I'm going to start at the edge, but starting in a hole would be similar. So you would just go along your line. Well, here, let me just go to this line.